recap video, very quick, on chapter 19, that's vectors. Vectors have magnitude and direction. Examples include acceleration, force, velocity, displacement. Whereas scalars, they're different, they only have magnitude. And examples include mass times speed, distance. So vectors are written with two components, an I component and a J component. And the I component is your horizontal component and J the vertical. So that vector has a horizontal component of A and a vertical component of B. So it's a little like X and Y, X going across and Y going up. Now the magnitude of a vector that has a horizontal and a vertical component, A and B, to find the magnitude of a vector, it helps to draw a triangle, and the magnitude is going to be the hypotenuse of that right angle triangle. So whenever we see the magnitude, or we're asked for magnitude, think Pythagoras. And we're just going to take the value of A and B, square them, add them, take the square root, just like we would if it was a Pythagoras question. You will also be asked to find the direction. Whenever you see direction, think trigonometry. And it's just basic trigonometry, and it will always be a tan of X. So a couple of examples. First question, there is a vector 4i plus 5j. If I was to draw that, it would look like this triangle here. So 4 across, 5 up. So 4 to the right and 5 up. To find the magnitude, if we draw a sketch when the magnitude is going to be the hypotenuse of the triangle, so we'll square and add 4 and 5, and then take the square root. The magnitude of the vector 4i plus 5j is the square root of 41. It asks as well for the direction, and the direction that we want is the angle that, this angle here, x, now it's the angle between the magnitude and the horizontal part, so the angle attached to the I part. Therefore we're going to be doing tan of the angle. So tan of this angle x is equal to the opposite divided by the adjacent. We're just using the 5 and the 4, we don't have j and I included, so we will do inverse tan of 5 divided by 4, and the angle is 51.3 to the horizontal. Just at this point, remind you that 4i plus 5j looks like this, goes across and then up. 4i, 5j goes to the right and up because they are positive. If it was, let's say, minus 4i minus 5j, well then we would draw it like this, across to the left and down. But what you'll notice is that whenever we come to work out the magnitude, it's still the same, because whenever we square a minus 4 and a minus 5 and add them, we'll still get the square root of 41. Next type of question was an exercise 19b, and it's the same thing. It's just finding the magnitude of all of these vectors, but we're linking it to velocity and speed, and also to displacement and distance. So what we're really doing is we're converting from a vector to a scalar. And to get from a vector to a scalar, you get the magnitude of it. So the magnitude of velocity is its speed. If you have displacement and take the magnitude, then you end up with the distance. Question 1, the velocity 6i minus 8j. If you were to draw that, it would be across 6 and down 8. 6i, 8j. So our magnitude would be the hypotenuse of that triangle. So then we'll do 6 squared plus 8 squared, take the square root. We get 10. It's still in meters per second. For question 4, I've skipped on because it's displacement. If I wanted to draw this vector minus I plus 2j, it would be across to the left and up 2. And the magnitude would be the square root of 1 squared plus 2 squared, and then take the square root. So square root of 5, whatever that is, and we're still talking about meters. Next type of question is the resultant of forces. So this is basically just whenever we combine, in this case, 3 forces all together. So all of these forces, even though they're vectors, they all act on a body. And the resultant of the force, to figure out what the resultant is, you'll just add them all together. So there's 4i. You're going to add on 5i, and you're going to add on a minus 3i. So 4 plus 5 minus 3 gives us 6i. Then our minus 2j, minus 2 plus 3 plus 1j gives us 2j. So to find the resultant of two or more forces, just add them together. Next exercise was whenever we have the resultant, we know what it is, but we don't know what one of the forces is. So P is unknown, but we know these two forces, and we know the total resultant is 2i plus 3j. So these three forces, P, 3i plus j, minus 2i plus 4j, gives us that as a resultant. So we'll just add these two forces together to get i plus 5j, and then move everything across. So 2i subtract I is I, 3j subtract 5j is minus 2j. And we're talking about newtons here, so don't forget your units. 19e, we're going to start applying F equals ma. So we have a force, another force acting on the body with a mass 5, and we're looking for acceleration. So here's our equation. Force is equal to ma, but this force is a resultant force. So we add together the forces that were given. So it's always the resultant force is equal to mass times acceleration. Our mass is 5. This is what we're trying to work out. So add together our resultant forces to get 5i minus 15j. That equals to 5a. So then divide through by 5. 5a divided by 5 is I. Minus 15j divided by 5 is minus 3j. Don't forget your units. 19f is using F is equal to ma and also our SUVAT questions. So this is questions that have constant acceleration, so we can use SUVAT. First part, well, let's read the question. We'll have a mass, we'll have an initial velocity, so that's v. We have an acceleration a, and we have time t. We're looking for force. So if we're looking for force, we're going to use force is equal to ma. So we have m, we have a. So for part A, we'll do force is equal to mass times acceleration. So acceleration multiplied by 4. And there we go, 4i minus 12j. Second part, find the final velocity. Final velocity is v. So we have u, a, and t. So then v is equal to u plus at. So there's u, that's t, and that's a. Multiply this out, and then add up your i's and your j's, and you get your v. Don't forget your units. Part C, displacement after 3 seconds. We're not going to use v equals u plus at. We're going to use s is equal to ut plus half at squared. And just be careful with multiplying out your vectors. But whenever you do all that, you should get 13.5i minus 19.5j. So that's one or two questions of every exercise on that chapter, apart from 19g. We skipped on ahead, but we can come back to it. But that's very short. So that's a very, very quick run through over vectors that should help you with any future homeworks.